All right, I always called these arithmetic sequences, but then I heard someone much smarter than me call them an arithmetic sequence, and I'm like, that's probably right. But I'll probably keep calling them arithmetic sequences. A sequence, again, is like a set of numbers with a pattern, and an arithmetic sequence is one where you're adding the same number as you go down the line here. So you're looking at the term numbers and you're like, oh, I see as I go down, I'm adding 5 each time. That would be an arithmetic sequence. A geometric sequence is when you are multiplying as you go down the line there. So today we're going to focus on arithmetic sequences. Tomorrow we'll focus more on the geometric sequences. But a lot of times they'll say like, oh, figure out if it could be an arithmetic sequence. So you're seeing, are you adding the same numbers as you go down the line? And if you're like, I don't know if you're adding the same amount, what you can always do is you could take any term and you could just subtract the term before it. So if you did 2 minus negative 3, that's really 2 plus 3, which is 5. If you did 7 minus the previous term, you also get 5. If I did 12 minus the previous term, 12 minus 7 is 5. So each one of them, if you subtract the previous term, you get 5. So yes, as we go down the line here, we're adding 5 each time. So could it be arithmetic? Yeah. If so, find the common first difference and the next term. I think that's supposed to say find the common difference first and then the next term. All right, so the common difference is what number are you adding each time? We're adding 5, so let's call the common difference is 5. And then the next term, if we kept that going, 17 plus 5 is 22. Cool. So if you are adding the same amount, it is an arithmetic sequence. So here, are we adding the same amount? Well, I see it's going down, but is it going down by the same amount? So negative 4 to negative 12 is dropping down 8. And it's fine if it's subtraction. We would just say we're adding negative 8. But if we kept that going, negative 12 to negative 24 is down 12. So as soon as there's a difference there, it's not an arithmetic sequence. No. And if it's not, we don't have to keep going. Because there is no common difference. We're not adding the same amount. We could probably figure out the next number in the pattern, but we don't even need to. Let's go down to C. Now again, I see it's dropping, and that's fine. From 1.9 to 1.2 is dropping down 0.7, so minus 0.7. This also works, minus 0.7, minus 0.7. So every time we're subtracting 0.7. So yes, it's an arithmetic sequence. When we're saying the common difference here, the common difference is saying what are you adding each time? We're adding negative 0.7 each time. So that would be our common difference. So you have to put it as addition. So even if you're subtracting, you'd say you're adding a negative number. And the next number, if we kept that going, would be negative 1.6. All right, last one. I don't know what we're adding, but we could check like one term minus the term before it, 11 thirds minus 11 halves, and we could see if that's the same thing as 11 fourths minus 11 thirds. Okay. Now, fractions, you got to have that common denominator, so these could both be 6. So it'd be 22 sixths minus 33 sixths. So it's going down 11 sixths. That's cool. We could be adding negative 11 sixths. Here, if we get the same denominator, we get 33 twelfths minus 44 twelfths, which would give us negative 11 twelfths. That's not the same as negative 11 sixths, so it is not an arithmetic sequence. Fun! All right. All right, so here's the general rule for an arithmetic sequence. Remember, a sub n is like the term number of this sequence. A sub 1 is always the first term, plus, and it's always going to be n minus 1, the term number minus 1 times d. d is the common difference. Once you see it set up a couple times, you'll think it's pretty easy. So find the nth term of a given sequence. Find the 10th term of this sequence. So we're looking for a sub 10 equals, well, a sub 1 is the first term. The first term I see is 32 plus n minus 1, and then it's times our common difference here. So the common difference is what are we adding as we go down the line here. Now I see it's going down. It's going down 7. So our common difference would be negative 7. Oh, shoot. We already know the term number we're looking for. I don't know why I put n in there. We already know we're looking for the 10th term. Let's do this. Let's write the general rule for it first, a sub n, and now we'll evaluate it for 10. So this would be a general rule where they're like, oh, find the 10th term, find the 32nd term, and find the 500th term. And you could just drop them all into this equation. So if we're looking for the 10th term, we're doing 32 plus 10 minus 1 times negative 7. 32 plus 10 minus 1 is 9 times negative 7. We would do the multiplication next. 9 times negative 7 is negative 63, and then 32 minus 63 is negative 31. So the 10th term would be negative 31. Now I've seen it other ways too. Once people have the general formula like this in pink, if you have to find a bunch of terms, if they're like find the 5th, 10th, and 12th terms, what I've seen done is like people have distributed this negative 7 to both those terms. So let's see, if we did that, we'd have 32 negative 7n, and then negative 7 times negative 1 is positive 7. And they just clean up this formula. So it'd be negative 7n, and then 32 plus 7 is 39. So some people would rather use this formula if you had to do it for multiple numbers. If you're just putting in one number, it's not worth the time. But like here, if you were like, all right, I need the third term, you're like, okay, negative 7 times 3 plus 39, that'd be negative 21 plus 39 is 18, which they gave us the third term. But like, oh, now how about the 100th term? So you could do negative 7 times 100 plus 39. Negative 700 plus 39 is negative 661. So if you have to find multiples, that's a nice little trick to know. But it'll still work here. It's like, what's it going to take you 30 seconds longer? I don't know. It just gives you a couple options here for you. So find the 11th term. Let's set up the general rule for these, and then we'll find the 11th term. Because I think setting up the general rule is a nice little skill to have. So a sub n equals our first term here. Our first term is negative 3 plus. It's always going to be n minus 1. It's always the term number minus 1. And then times our common difference. What are we going up by, or in this case, down each time? Our common difference, it's going down by 2, so we would say our common difference is negative 2. Cool. Now they're saying find the 11th term. Negative 3 plus, we have 11 minus 1 times negative 2. 11 minus 1 is 10. 10 times negative 2 is negative 20, and negative 3 plus negative 20 is negative 23. So let's try the general rule for this one. A sub n equals our first term, 9.2, plus, it's always n minus 1, times our common difference. Now, that's kind of hard for me to see what we're adding, or in this case, subtracting each time. What you can always do is take any term and subtract the term right before it. So if I did 9.15 minus 9.2, or if we're thinking like $9.20, that would give us negative 0.05, negative 5 cents essentially. So that would be our common difference. It's going down by 5/100ths each time, or like 5 cents. $9.20, $9.15, $9.10, $9.05. Now we're going to find that 11th term. Oh, geez. I can't write plus signs no more. 11 minus 1. So 11 minus 1 is 10. 10 times 5 cents, it's 50 cents. So we have 9.2 plus negative 50 cents. If you have $9 and you give me 50 cents, you have $8.70, 8.7. All right, I forget what else we have in this set of notes. There it is. That's it, man. That was almost fun. Almost.